Hi everyone, KubeVirt technology addresses the needs of development team that have adopted or want to adopt Kubernetes but is using virtual machine-based workload that is hard to containerize. As we know, KubeVirt has become a CNCF incubating project since April 2022. In Red Hat, we have the OpenShift Virtualization feature that's available on the Red Hat OpenShift platform. So you can easily deploy these capabilities and feature via the Red Hat OpenShift Virtualization operator. And what you get is really virtual machines that can run in containers managed as pods and using the KVM hypervisor in this case. So it will be able to be scheduled, deployed, and managed by Kubernetes, and that we are able to integrate with the container orchestration resources and services as a result of which. So traditional pod-like SDN connectivity will be available to the virtual machine that's running inside the pod. If you need to connect to external networks, you can also leverage on Malta's capabilities for that. And we are able to reuse the same kind of storage paradigm in this case, the likes of PVCs, PVs, storage classes, etc. So in this series of demo videos, we are going to showcase the various use cases that can be achieved by using the Red Hat OpenShift Virtualization feature and functionalities within the Red Hat OpenShift environment. So we'll move on to the demo next. So before we start to look at all the various use cases that we will be showing, let's look at what we have in this environment itself. So over here, we have a 4.11 OpenShift cluster being deployed. So the cluster itself is deployed on a 3-node compact setup, whereby we have 3 bare metals being set up and used for this particular cluster, each of them running the master and worker role. So if we were to check on the nodes information, well, we can see that these are the internal IPs of the nodes that we have actually deployed for the 4.11 cluster. So we do need to set up other informations in order to be able to use the Malta's networking capabilities for this environment. So we know that it is not uncommon to have VMs with multiple NIC cards. And in order to achieve that, we will need to leverage on Malta's. So in my environment, I have the bare metal having 2 NIC cards. The first NIC will be used for the OpenShift SDN connectivity, while the second one will be used for management network, whereby what we will do is to leverage that to perform things like remote desktop management for Windows VM, and for Linux RHEL VM, we will be using it to perform SSH onto the VM directly. In order to achieve that, we do need to define policies. In this case, a node network configuration policies. What we have is to set up and tie the EN01 port with a Linux bridge. And the network attachment policy itself, we also create the CMV bridge network over here, right, leveraging on the PRR1 bridge. So if we were to go and check on some of the stuff that we have already set up beforehand, you can see that all these policies are actually available on all the various bare metal nodes that we have already set up. So if we were to log into one of them, we can see that BR1 as well as EN01 has been defined properly. With this, we will be able to leverage on Malta's and multi-network NIC card capabilities to have virtual machines running in pods that leverages on multiple NICs and multiple networks. Other than the OpenShift virtualization setup that we have, we can see that we have also set up the storage operator. So in this case, we are leveraging on the OpenShift data foundation. What we have set up is leveraging on the storage operator. So you can see over here that we have a storage system that has been set up. So it's what we have for the block file as well as the object storage that exists within this cluster itself. We will be using Ceph RBD for the most part. Other than this, the other things that we need to set up will be the OpenShift Virtualization operator. So KubeVirt hyperconverge has been set up. What we have over here is to ensure that the cluster is being set up so that we can use the OpenShift virtualization capabilities. Lastly, what we have is we will be leveraging these capabilities on a particular namespace that, for demo purpose, I'm calling it the KubeVirt-VM namespace with various workloads that is running. So if you look at the networking piece, this is actually already defined over here in this particular namespace with the same kind of definitions that we have actually set up as what we saw earlier with the YAML files, right? Going back to the virtualization, so you can see over here that this is the overview dashboard. We are able to see what are the various virtual machines for each of the template itself. So 6 different virtual machines running. We can see what are the top consumers based on matrices like CPU, memory, throughput, for instance. These are all the various VMs that I have running within this environment itself. We have the capabilities to look at service catalogs. So we have actually set up various sources in order to be able to speed up the virtual machines accordingly. So you can see over here that other than the Red Hat Enterprise Linux catalogs, we also have that for the Windows servers itself, including things like Windows 10. So looking at the templates, we also have capabilities to create golden image templates. Other than that, within the virtual machines tab, you can actually see all the existing VMs that is already up and running within the environment. So each of them is running on various different nodes. For instance, you can see that 4 of these virtual machines are running on master 2 node and the other 2 are running on master 1. So let's just look at how we can actually create virtual machines using the template itself. So from here, we can actually come and just hit create from catalog. We can go down to the Windows Server 2019 VM. So from here, you have various attributes that exist for this particular catalog. So we can say that we want to customize the virtual machine. It's going to give you a random name, right? So you can always change the name depending on the needs and requirements. I am putting from default disk source. I have already created a template that I want to use for setting up the Windows Server 2019 virtual machines. There are optional parameters that you can set up as well, right? We are mounting Windows drivers disk in this case so that we can actually set up any required drivers accordingly if any of those are missing. So then what we do next is that we will review and create the virtual machine. So in this case, I have the CPU running as 1 CPU and default 4 gig of RAM. So let's say if I wanted 2 CPUs and 8 gig of RAM, so I can save it. And after which, there are other things that I can actually set up. So in this case, you can set up the scheduling capabilities to define which node you want it to go to. I'm leaving it as a default for now. Environment information, do we have any config maps or other information that we want to pass in, right? Network interfaces, you can see over here that we are running just 1 single NIC using the port networking at this point in time. We can add another network interface card. I'm using E1000E, which really will work just out of the box for Windows servers. I'm using the CMV bridge network that I have defined. I'm not specifying any MAC address. It's going to help me to auto-generate one, as you can see over here, right? Then other than the 2 NIC cards that we have set up, I can also set up different disk that's available. So for instance, in this case, I can actually just click add disk, right? Then again, I can say that I want a second hard disk that has 10 gig of disk space, right? The interfaces itself, I probably just select SCSI, right?
And the storage class, I'm using the Ceph RBD storage class in this case. And then I save it. So you can specify other scripts like sysprec, for instance. If you have other metadata like labelings that you want to give for these virtual machines, you can do so. In this case, I'm just going to add an additional network interface as well as a disk for this virtual machine, and I'm going to hit create. So let's wait for a while. So it's waiting for volume binding. At this point in time, it's going to start up the virtual machine in a short time. So now it's starting. Okay, so it's booting up with 2 CPU, 8 GB RAM. So we go to the console. All right, the virtual machine is up. So what we can do is we can just try and log in from the console. So we are in. What we can do is we can do a rescan of the disk. So we can see that the 10 gig disk is not visible from the screen over here. So what we can do is to search for device management. And we can see that some of the drivers, for instance, for SCSI is actually missing. So what we can do is we can say update drivers, and we can search for the disk that we have already mounted when we boot it up, right? So this will be the one. So then, we can do the same thing for the other stuff. Right. So in this case, we have everything properly installed. So with that, we can rescan the disk again. And here we have, right, the 10 GB disk that we have actually attached to the virtual machine when we set it up. Right. The other stuff that we can see, of course, is that we actually have 2 NIC cards because we are using E1000E, right, rather than the Virt IO. We will be able to see this thing just out of the box, right? It has actually 2 NICs in this case. The second one is attached to the management network that we have set up during the initial setup. Right, so this is what we have for this particular VM. Other things that we can do with it, we can actually just change certain things, right? So for instance, I can say that I need 2 more CPUs and 10 GB of RAM instead of 8 GB of RAM, right? So this changes actually requires the virtual machine to be restarted, right? So we can just save it. So it will not get applied until we reboot, right? So the next thing that can happen, of course, is this hot plugging of disk, right? We can actually do this without a reboot if it is a hot plug. So let me just show a hot plug of a disk before we do the reboot, right? So in this case, we say that I want to add a 1 GB disk, right? Hot plug using SCSI interface. We can save it. So this is a persistent hot plug that have been plugged onto the virtual machine itself, right? So we go back to the console. We just have to do a rescan. And now it's able to see that 1 GB disk as well. So here we are able to very easily just slot on a new disk onto these virtual machines, right? So in order to then show that we are able to increase the CPU and the memory as well, we just need to come over here and we do a restart. Right? So what it does is that we will be able to just do a reboot of the machines, and it's just going to do a reboot, and after which the settings that we have already put in will then be applied onto the virtual machines. So you can see over here that other than the restart option, we can also stop, we can pause, we can clone, various features like editing the labels, annotations, and delete. Of course, we can do things like live migration as well for this particular virtual machines, which we will show in the later use case demo as well, right? So now we can see that the VM is being booted up. And here we are. So the next thing that we can see over here from the details is that now it is running on 4 CPU and 10 GB RAM. Over here, I have another 2019 Windows virtual machines that is actually running with the 10.69.151.7 IP address, which is running on the management network. So if we were to go into it, we can see that it has 2 NIC cards as well, right? So let's just show everyone, right? So this is actually running on NIC card number 4, right? So if we were to just look at the properties, this is what this is running on, right? That was what was configured. The status itself, can also see that it's running on 10.69.151.7 IP. So we just want to ensure that we can do a remote desktop into this particular machine, right? From my laptop, you can see over here that this is my MacBook, right? So what I'm going to do is that I'm just going to log in. And here I am, right? Inside that virtual machine that we were looking at earlier on, right? So very easy for us to just go in, right? So I am able to just easily access this, and from the screen behind, you can see that immediately it logs out whoever is logged in earlier because I'm using the same user, right? So this is the expected behavior. And then this means that we can very easily do management of the Windows machine. If we want to have, for instance, some network that is used for backing up, for instance, we can just set up another NIC card accordingly and use that for that capabilities. So other than this, what we can do, of course, is to try to log into other VMs that is non-Windows. Over here, can actually just log into this particular virtual machine that's running on the 10.69.151.3 IP address. So let's just get in using the cloud user. So let's just make sure that this is the same virtual machine that we are talking about. So what will happen over here is that we are at the console of the RHEL 9 virtual machine. So if I touch a file, and if we were to go back over here, the same file that has been created, text.txt. Right, so this is what we have. One of those things that we can show, of course, over here is how we can actually perform things like a live migration. So same thing, right? If I were to come in over here and I do ping towards the Google DNS, right? The next thing that I can do is to migrate this virtual machines. So let's just go back to the tab that shows virtual machines. We can see that the RHEL 8 test VM1 is running on master number 2. So what we do over here is we just say that migrate to a different node. And it is going to start the live migration without any drop in traffic. So you can see that now it's in the migrating state. And now it moved to master 0. successfully without any issues. If we were to go back to the console, we can see that the ping remains consistent. There is no packet loss as well. So we are able to very easily do a live migration of the virtual machines. So live migration features works as well. One of the other stuff that can be quite easily achieved as well will be things like doing the expansion of a PVC, right? So we saw how we are able to add disk onto a Windows virtual machine earlier. What we can do over here, of course, is we can actually say that we want to expand the disk, right? So this is the test VM1. So if I were to say expand PVC, the total size is 32 rather than 31 gig. If I hit expand, it is going to expand the disk itself. Going back to the virtual machine, you can see that right now it's 31 GB, right? So what we need to do is we just have to do a reboot. So now it's running 32 GB, right, as opposed to 31 GB before the expansion. So we can very easily just expand the disk itself. You see the partition has actually expanded as well, right? So, all these are capabilities that can very easily be achieved. Okay, this is what I wanted to show for the first part of the demo. We will continue with more demo use cases on the next part, where we will be looking at things like how to perform migration of virtual machines from vCenter and from the Red Hat virtualization towards the OpenShift environment using what we call as the migration toolkit for virtualization. So stay tuned for the next demo video. Thank you and see you soon.